Welcome to session 32. Today we focus on right triangles. They are the most useful shape on the whole SAT because they show up in geometry, in trigonometry, and even in algebra word problems. By the end of this lesson, you will find any missing side with the Pythagorean theorem, recognize the common triples instantly, and use the two special triangle ratios with confidence. Here is a right triangle. The two sides that meet at the right angle are called the legs. The longest side, sitting directly across from the right angle, is the hypotenuse. The Pythagorean theorem ties them together. Leg A squared plus leg B squared equals the hypotenuse C squared. Let's try it with legs of 9 and 40. Square each leg and add. 81 plus 1600 gives 1681. The hypotenuse is the square root of that, which is exactly 41. So 9, 40, 41 is a Pythagorean triple, a whole number right triangle worth remembering. Some right triangles appear over and over on the SAT. If you recognize them, you can write the answer without doing any arithmetic, which can save you 30 to 60 seconds per question. The most common is 3, 4, 5. Double it for 6, 8, 10, or triple it for 9, 12, 15. Then learn 5, 12, 13, 8, 15, 17, and 7, 24, 25. And remember, any multiple counts too. So the moment you see legs of 9 and 12, you can write 15, because that is just 3, 4, 5 scaled by 3. Now, two special triangles that are printed on your reference sheet, so you never need the theorem for them. First, the 45, 45, 90. It is just an isosceles right triangle. Because the two acute angles are equal, the two legs are equal. Call each leg x. The hypotenuse is x times the square root of 2, which makes it a little longer. So the sides are always in the ratio x to x root 2. Suppose the hypotenuse is 12. Divide by root 2, and the leg comes out to 6 root 2. The area is 1/2 leg times leg, which is 36 square units. And here is the classic trap. The hypotenuse equals the leg times root 2, so it is always longer than a leg, never equal to it. The second special triangle is the 30, 60, 90. Here the three sides are all different, and which side is which depends on the angle it faces. The shortest side is opposite the 30-degree angle. Call that side x. The side opposite 60 degrees is x times the square root of 3. And the hypotenuse, opposite the 90-degree angle, is 2x. So the ratio, from smallest to largest, is x, then x root 3, then 2x. For example, if the hypotenuse is 20, then 2x is 20, so x is 10. The short leg is 10, and the long leg is 10 root 3. These triangles power three shortcuts you will use again and again. A square is 2 45, 45, 90 triangles, so its diagonal is the side times root 2, and its area is the diagonal squared over 2. An equilateral triangle splits into two 30, 60, 90s. That gives a height of s root 3 over 2, and an area of s squared root 3 over 4. And the distance between 2 points is simply the Pythagorean theorem on the coordinate plane. The square root of the change in x squared plus the change in y squared. From the point 1, 3 to 5, 6, the horizontal change is 4 and the vertical change is 3. So the distance is the square root of 16 plus 9, which is root 25, exactly 5. Your turn. A 13-foot ladder leans against a wall, with its base 5 feet away from the wall. How high up the wall does the ladder reach? Pause the video, draw the right triangle, and solve. The wall, the ground, and the ladder form a right triangle, with the ladder as the hypotenuse. So 5 squared plus h squared equals 13 squared. That means h squared is 169 minus 25, which is 144. The square root of 144 is 12, so the ladder reaches 12 feet. Notice this is just a 5, 12, 13 triple. Let's recap session 32. The Pythagorean theorem says a squared plus b squared equals c squared, where c is always the hypotenuse. Memorize the triples 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. The 45, 45, 90 has sides x, x, and x times the square root of 2. The 30, 60, 90 has sides x, x times the square root of 3, and 2x. And the distance formula is just the theorem on the coordinate plane.